All right, fingers crossed we're going to work this time. Good. That's actually X bar, and that's Y bar. Sorry, the symbols didn't come up. Random guess, Tim, or did you work it out? Guess or work it out? Worked it out? You've got about 5 seconds left. That's one of the issues that I want to address, all right? You have 2 minutes. 2 minutes per mark in the exam, all right? That's why we're practicing this. So, that bar's in completely the wrong spot. It's going to have to go up there, because I need that. Okay, so there are a couple of formulas there. Did anyone find the formulas in their summary book? Yeah. Yeah, what are they? Yeah, what are they? Read them out. M equals?
R and then SY over SX.
Equals R, SY over SX. Okay, so that's going to get you the gradient, okay, which in this is the B. So if you actually calculate M and you work out using the R value and SY and SX value, you will get M being 1.52, is that right? Yeah? So that as soon as you do that one calculation, you've got rid of D and E. All right, as soon as you do that one calculation, D and E can't be there, okay, because they've got the wrong gradient. Now, C is what? What's this second equation? Sorry? What's the second equation? How do you know C is negative?
Well, it can't be negative because all the top is positive.
Okay, but what's the actual equation? C equals Y bar minus M X bar. Okay, so if you work out, you've just worked out M and it's 1.52, negative 1.52, then you've got this equation here. Straight away, you should be able to do that. If you didn't find those formulas in your summary book, that's where they need to be. All right, so you need to say, if I am given in your summary book, if I am given R, X bar, standard deviation of X, Y bar, and standard deviation of Y, these are the formulas I need to use. All right? I'll give you a couple of seconds to write them down.
Were they in the books this time, okay? So I had never seen them before. I don't think they were, but they were in the textbook.
They're in the textbook, and if you've done the questions for that chapter and you had to come across it, I would have pointed you in the right direction. All right? All right. They are in the textbook in one of the, yeah, 3, just above 3C. All right, just.
What does the C equals? What's that?
C is the y-intercept, so that's this A. All right. Got him? Yep, ready for the next one? Oh, you can't see the data. We'll just do that. That'll keep it well and truly out of the way. You just won't be able to see who gets it right. It's a projector. I don't know. There's one in C. C6 does the same. I don't know why. It's just that brand. It is frustrating. What are you doing? Resting. Oh, packed away. One thing I didn't manage to fix, guys, was that's actually x squared. So if you see x2 on any of them, it actually means x squared. Sorry about that. Are you noticing these questions are a lot harder? A lot of you aren't answering them anywhere near as quickly.
Yeah, they're really.
What's the problem, Michaela? Are they hard, or have you not got your summary book up to scratch, or where do you think the issue is? Probably both? All right, so 2 of the people that answered got that right. The correct answer is A. Okay. Why? How should you have done that? You just guessed? Okay. All right. What I would have done, and again, you guys don't have the advantage of being able to draw on it. On your calculator, I would have typed them in and then put an x squared column in.
Yeah, I typed them in and forgot about the x squared.
Okay. Then you do that x squared column, you graph it, and you fit a line of regression. All right, that's all you had to do. I know that sounds like a lot, but typing that data in is going to take you, what, 30 seconds? Then applying the x squared transformation takes you no time, because you go to that grey square on your calculator and you type equals whatever x was squared, okay? And then you fit a regression line, which is it takes another 3 seconds. All right, so in theory, you can do that question in 1 minute or thereabouts, if you're quick on your calculator and you know what you're doing. Now, I will warn you now, there are other questions like this. Okay, this is the most common question that I found to do with transformation on the exams, okay? So if you did that column, on your calculator and then fitted a least squares regression line between x squared and y, you would have come up with A, okay, as the equation, although it would have just had x, not x squared. All right, but remember, you've got to transform that data because you're graphing it against x squared. Does that make sense? Yeah? I won't use a white font again, that's kind of hard to read, isn't it? Sorry guys. Stop you sucking, you're not even doing the quiz.
How are you meant to work that out from, say, 3.5 centimetres or anything? I get it.
All the measurements are in millimetres. All right, that would have been in the previous question. Like this is a second part of a question sort of thing. All right, so correct answer is C. Those two who got it right, did you work it out? And if so, how? Or was it just another one of those random guesses? Half guess. This is one thing that I keep telling you guys you need to practice. There is an equation up there, but what does it mean? Okay, and this has been asked several times in your exams. Here is an equation. What does it mean? I just helped Son with one. What does that equation actually mean? All right, so we've got the gradient and the y-intercept. Okay, so the gradient's there, the y-intercept is there. They mean different things. Okay, in relation to diameter and length, they mean different things. So which of these sentences makes sense? Does it say there is a 3.5 millimetre increase in diameter for each 1 millimetre increase in length? No, all right, because we're talking diameter. For every increase in diameter, the gradient increases by how much? Sorry, for every increase in diameter, what does the gradient do? Increase by 0.87. So it needs to be a 0.87 increase of length for every increase in diameter, doesn't it? That's what that equation is saying. For every 1 millimetre increase in diameter, you're going up 0.87 of your length. Does that make sense? Why not, Adrian? Where's the stumbling block? Too many words and numbers? If you read that equation, length,
What's the 3.5?
forget about the 3.5 for now. Length is 0.87 times the diameter. So for every 1 millimetre the diameter goes up, the length is going up 0.87, isn't it? Okay, now, so that puts us down between C and D, doesn't it? Okay, because they're the only ones that have 0.87. Now we deal with the 3.5. Do we need to deal with the 3.5? No. Why not?
Because there's nothing about 3.5.
Right, there's nowhere in there about 3.5. They've put answers in A and B about 3.5, but we know that the increase is 0.87. But what is now, we've got to talk about what the increase is in. Is it an increase in diameter causing a 0.87 increase in length, or is it 0.87 increase in diameter causing an increase in length? I think I just said the same thing twice. Sorry. There is a 0.87 millimetre increase in diameter for every millimetre of length we add, or is there a 0.87 millimetre increase in length for every millimetre of diameter we add? First one, second one. For every increase in diameter, okay, 1 mil gets added to the length. Okay, so it should be the first one. Okay, so for every millimetre in, no, this is why we need to practice it, okay, because even I can get confused. Read it carefully. There is a 0.87 millimetre increase in diameter. That's not what's happening, is it? It's happening to the length, because the length, and as we said, if we ignore the 3.5, length is 0.87 by diameter. So for every increase in diameter, we're adding to length. So it's not C.
It come up right. Why are you doing 3.5?
It's D, isn't it?
It is D. I've obviously put the wrong answer in. All right, sorry about that. Why are we ignoring 3.5? Because they're only talking about an increase. All right, and 3.5 doesn't change. 3.5 is the y-intercept. That's where it starts. So if you have no diameter, as you approach no diameter, you get close to 3.5 millimetres in length. But they haven't mentioned that there.
Yeah.
All right. Where did they pull 4.37 from? Before we move on to the next question. They've added those two numbers together, haven't they? Just to see if you'll fall for that. All right. Remember, they're trying to rank you. They're trying to trick you to work out whether you know what you're doing, you don't know what you're doing, or you really know what you're doing. All right. Yep. No, not those ones. Those ones. How's that?
Maybe it's a little. Maybe you need to wipe the whiteboard or something.
I reckon all lights It's like a reflection off of where it's hitting.
Yeah, that's the actual projector though. I can't change that.
When we finish this, I need a bit of help with that big. Just figuring this bit out.
All right, so we've got 4 of you now answered with 20 seconds to go. And a lot of you are still working on the calculator. Do you know what you're doing? Yeah, I've given a bit of extra time. All right, you've now got 2 minutes and 15 seconds. All right, we're trying to work out how much time you need to answer this question.
But not all the questions in the exam are going to take 2 minutes, are they?
No. So we're up to 2.5 minutes.
Some are going to take longer than others.
Yep, and that's why we're trying to work out how much time you need. All right, so you've just had 2.5 minutes. 2 minutes 45. You're not going to answer? Carly, you still going? Yeah? Stuffed up? All right. So that could have gone to about 3 minutes. Okay. Now this is where it comes down to time management. Who was just telling me that some questions are going to be longer than others? Sana. You're dead right. Some questions you guys will be able to answer. The early questions, questions 1, 2, 3, 4 out of each module, you should be able to answer within about a minute. Right, which gives you a minute spare. But why do I keep giving you only 2 minutes? Is it to stress you out? Yes. It's to get you used to that sort of time frame to answer a question. All right? You need to be able to do it in that time frame. So, those of you who got it right, did you calculate or guess?
I guessed the last question.
So guessed? Calculated? Guessed?
No, I was calculating, but then I typed in the wrong thing.
Okay. All right, so the same thing applies with this one, guys. All right, what you need to do is add a column or add a row to your table. Okay, and it's a log y. Okay.
I want to delete all the data that I've put into my calculator.
What I do in you control up, delete every page.
Yeah, it's wrong. It's not working.
Right, and then exit the document and open a new document. Then you've got a completely fresh set, in theory. That's how I've been doing it. I don't know whether it's going to work for all of them or not. All right, and then you graph x against log y, fit a line of regression, and you should come up with, what did we decide the answer was? D. You should come up with that. All right. Now I can guarantee you, if you do graph of x and y and fit a regression line, that'll be one of those 5 options. Okay. If you do a log x against y, that'll be one of those options. So they'll have all the options there just in case you stuff up.
What do you put in the calculator? What do you put in the third one, log y?
Yeah.
Is that what you type in?
Well, you'll label it log y or ly or something like that,
Go to the grey
and then you go to the grey square equals. So you press enter, so you get the equals sign. Then you just type log y.
So put log y at the top. No.
No. You won't be able to label it log y, I don't think. You'll have to label it something else.
And then go to
The grey square and enter log y.
Yeah, that's why it didn't work for me because I did x squared on the top one and it didn't work.
Okay, yep. All right. Ready for the next one?
the rest of the question.
Least squares regression line predicts that the weight in grams of a fish of length 30 centimetres would be closest to, and then your answers are over here.
Oh, is that the end of the question?
Yeah, we don't.
I guarantee if you haven't answered by now, you're overthinking it. All right, and this is one of those questions you should be able to answer in about 30 seconds to a minute, right, and get it right.
What number question is it?
This is an 8. All right, and that's, as I said, I think 2008 was an easy exam. I think we've said that in the past. The questions on 2008 seem really easy. Who hasn't answered? We've still got 9 of us? Yeah. Someone hasn't pressed enter? Was it Sana? All right, well, if everyone reckons their answer, I'm going to take the time off. Do you want me to check? I'll check that it's the right answer. 2008 should be D. Okay. Now, the interesting thing is I said you should all get it right. How did you do it?
Looked at 30 centimetres and went across.
Yeah,
So you went
I did the exact same thing.
up 30 centimetres and then came across.
Yeah, it's like 262.
Ah, I did the dot.
So how many of you did the dot? How many of you pulled up that dot and went, well, it's less than 250, therefore 240?
Yeah, right.
All right. There's one issue fixed. Okay. If you rule across, it reckons it predicts it at 274, okay? Which realistically is right about there. All right, now, according to the graph I see, that's about a 30.5 centimetre fish, okay? So perhaps I've read the exam question wrong, or perhaps when they marked it, they've tweaked it, all right? There was one exam question that I pulled from this quiz because every answer was right because there was a misprint in it. All right, so they do make mistakes, but I will go back and check that because I probably agree. I think it should be C. It's about 265, 262. All right. But then their callback might be its closest to. All right, so if you actually got a ruler and measured that, you might find it's 252. 260 something, all right, but 274 is closer to it than 262. I don't know. All right, I'll go back and confirm the answer for that one.
Oh, no.
It's easier than you think.
I have my glasses.
All right, one more to go, unless we're down to 8.
Yeah, that'll be me.
Are you going to go or not?
No.
No? All right. All right. This is one of those ones again where I've been saying you need to work out what it actually means. Okay? The correlation coefficient, the Pearson's thing of negative 0.6 doesn't tell you about percentages. Okay? R squared, okay, the coefficient of determination tells you about percentages. So if you're talking about percentages, you can cross off A and B straight away because percentages don't line up. Right? Because we're using the correlation coefficient, we're not talking percentages. So there's A and B gone. Now most of you chose A, am I right? Okay. The slope of the least squares regression line is 0.6. No, it's not. All right, definitely not. It's not what R says. Definitely not. So we need to work out which one of these two is most correct. All right, we're down to 50-50. You've done well to get to here. If a student spends less time watching TV, they will do more homework. Is that what the Pearson's product moment correlation coefficient says? You can't guarantee that, can you? All right. But an increased time spent watching television is associated with a decreased time doing homework. Okay? So we can't say if you spend less time watching TV, you will do more homework, but we can say there is an association between them. And that's the difference between those two basically, is that one word. All right? As opposed to they will. Okay? You can't say they will, you can say they may. You can say there's a link between them. All right? But you can't say they will. E is sleeping time, same as the others. Oh, there it goes. You still going, Ash? You got 2 seconds. Okay. Now, that was just a guess? Jess, you didn't even touch your calculator. How did you do it?
I got it wrong.
No, that's fine. How did you do it?
I read it.
Okay, so you read it and you decided one of those was right.
Yeah.
Yeah? How did you decide which one was right?
I didn't.
You didn't, you guessed. No. How did you decide to choose the one you chose?
Because the independent variable is sleeping time.
Right. It does say that, doesn't it? Using sleeping time as the independent variable.
So wouldn't that mean it's D or E? Because Y equals independent
Is All right, so you were on the right track, you just had them confused. Because I figured that's what you'd done, and I made the same mistake. I went, well, that means it's one of these two. All right, and then the answer came out with A, and I went, I know what I did wrong. All right, so sleeping time is the independent, which means it's the X. Okay, so it has to be A, B, or C. So we've crossed off D and E. All right, so we've crossed off D and E. So, Ash, did you do this question? Yeah? You were the first person to pick up your calculator. All right. Michelle, you picked up your calculator at about 1.5 minutes. Okay. Didn't touch your calculator, did you? Didn't touch your calculator? Okay, I didn't watch you guys. What did you guys do?
Yeah, I did mine on calculator.
So what did you do?
Just
Read the question, spent 30 seconds reading the question, then what?
then put Y and put in that, then did H, put in that.
Yeah?
Then went to my graph.
Yep.
Put hours as X and years as Y.
So how long did that take? To take that data there, put it into a table and fit a regression line.
A minute, a bit.
All right, bit over 1 minute. So you took 30 seconds to read it? Yeah? Did you, I'm telling you, you took 30 seconds, then you picked up your calculator. How long did you get it finished?
Yeah.
Yeah? Did you get the right answer?
I did A because I didn't look at the writing.
X and Y's. Okay. So another one, guys. I think, and I can't guarantee this, but I think as soon as you guys see a table of data, whack it in your calculator. Particularly if it goes over a couple of questions, which I think this one might. All right, because you can use that data again and again. Does that make sense? Now, I can't, like I say, I don't guarantee that's the best option, but it seems to be a good option to just, if you see data, put it in your calculator, then you can use it for stuff. All right?
Look, this was chapter 3. This is chapter 2.
But that doesn't mean I'm not going to go back and check your knowledge of them. All right, I will put sneaky ones in every now and then. Have you given up, have you, Michaela?
I'm giving up too.
Okay. Just on this question or full stop? There's about 3 questions left. All right. Adrian, you had your data in.
Yeah, I deleted it.
You deleted it before the question. You deleted it afterwards. All right. So in an exam situation, you wouldn't do that, would you? Because you'd know the next question had to do with it. All right. But you spent your minute putting your data in last question. You've got the data for this question. It takes you 2 seconds, doesn't it? All right. So this is why I'm saying, and you guys won't see this until you sit an actual exam paper and see how they're laid out, all right, which we might start doing a little bit of as we go. But a lot of the questions with this sort of data will follow. All right, so there might even be another one.
We just haven't practiced this because the questions are so much different. Like when we sit our SAT, And then like we get questions like these, they just seem like the total.
Alright, so we need to spend a bit more time. Instead of doing multiple choice, we might have to spend some time doing the long answer ones.
Yeah.
Alright, we can do that. But again, it means you guys are going to have to do exercises at home.
Then we have one with all multiple choice and
Yep.
another one short answers.
Yep. Alright.
Get the actual paper so we can write on it now.
Yeah, I will. Yeah, I won't do it on here, not for the short answer ones. I'll actually give you...
We should all work it out.
Alright.
We all do it and then work.
Okay, I'll work on that. So I don't think I need to write anything on this. Alright, data goes into your calculator. You do your... From your table, you do your menu 461 or whatever it is. No, it's 433 for that, isn't it?
And I did the wrong one, so I got like a meeting and all that, so whatever.
How do you do that one? 433.
Is it 433 in your table?
Y in the first box.
I think it's 433 in your table. It's 461 on your graph, but that doesn't give you the R value. If you do, maybe it's 431 in the table. 431 is one var stats.
That's going to be meeting and everything.
Yeah,
I deleted all mine.
that's right. I don't need it.
It's 461. Wait, no,
41,
411 or 413.
413. Okay? 413. Oh, whoa, 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 go back. All right, 413. I forgot. I wasn't writing. All right, so stop that. All right, next question's up. Hopefully, yeah. And there is another question after this that may be tied to this, all right? Yep. Yeah, I think that's because I've gone through questions and out of questions and stuff like that.
Turn mine off, Al.
Yeah, if you want. Did you get it right, Michelle?
Huh?
Did you get it right?
I don't know.
Do you think you got it right then?
No.
No? Okay.
That number's going crazy.
Yeah, it's because we've already done the question, I think. I think.
Yeah, it's done.
All right, anyone still going? Adrian, you still going? Yeah?
I know what I did, but I definitely didn't do it right.
Okay. How many of you put that data into your calculator? Did you get it right, Michelle? No. How many of you put that data into your calculator? This was one time when you didn't need to. I know I just said you should. This is one time when you didn't need to. This relies on you knowing what a residual is. Okay, they've given you everything you need to know to work out this answer in about 30 seconds. Everything you need to know. All right? They've given you the equation. All right? And then they're telling you they're predicting the baboon. You have the original value for the baboon. Now, residuals are the y predicted minus the y actual. I'm sure it's that way around. Okay? The predicted value minus, so y predicted minus the y actual. Okay? So if you sub in that 10.55 into that equation, you'll come out with a predicted brain weight. Then you get the original brain weight, you do your predicted value minus your actual value, and you will come up with whichever one is the correct one of them.
You
right?
It says actual y value minus predicted.
Always get it wrong. So that's actual minus predicted. Okay, sorry about that. So it's your y actual, so it's 179.5 minus the prediction you get by putting 10.55 into that equation. Yep. All right. So 30 seconds or so you should be able to get that right. But that relies on you knowing what a residual is. Okay? I should write it again. Y actual minus y predicted. Okay? So y actual minus y predicted is the residual. It's the distance between, on a graph, the point and the line. It's that vertical distance between the point and the line. Yeah.
My calculator's going to
Why does D have a 2 on it?
Squared. Yep. So how many are we down to doing it? Carla, are you still putting answers in? No? Michaela? You still are? So 1, 2, 3, 4, 5 then. So we've got everyone. Because Ash isn't doing it. Sonny, you're not either, are you, anymore? Oh, you haven't done yours. Sorry, Adrian. Yeah, it's because we've done this question as well, I think. We did 2 questions without knowing it. So that's it, you're done? All right. Okay. To answer this one, guys, you need...
What was the answer?
All right. Remember those graphs I drew up on the board last week? All right, the 4 graphs that did this, this. Yeah? One did that. What was the other one? I can't remember now. But if you had those graphs, this is shaped, you can clearly see it's shaped like that. Okay? So if you want to work out how to linearise this data, what you need to do is bring these x values back over here, don't you? So you're compressing your x values. You're squishing your x values up. All right? So if you had that in your summary book, you should have been able to get that right. All you're doing is compressing the values. You need to do, what was it, a log, internet use. Is that right? C? All right. So you're logging internet use to compress your x values back. Make sense? Get out of the way. Was that a random guess, Ash? So you've been in here 2 seconds, you got it right? What's up with that? Who's still going? You've stopped now, haven't you, Michaela? Jess, you're still going? Bless you. All right, anyone left? Let's get that out of the way. Okay. So, there was a way... No, that's wrong. That is so wrong.
Nah, it is.
That is so wrong. I must have got the answers wrong when I checked them, because that is so far wrong it's not funny. Okay? There was a way, we'll work it out right now. There was a way you could cross off 2 of these straight away. Where? Ah, no. I fell into the same trap. Alright?
So C is right?
Yep.
Wait, no, B.
B is right. Okay?
So why is it 141 though?
It's not crossing at 0 there, is it? What's it touching at?
See, it is B.
Alright? So I fell into the same trap because I didn't read the graph properly. Now the gradient you can find, okay, you go from about 167 up to about 174 in a run of 4. Alright, so rise over run. Okay, 174 minus 167 divided by 4 gives you about 1.3. Okay, which then crosses off that one and that one. Now, the other thing you can look at to cross off another one is height is your y value, so that crosses off E. Now you're down to a 50-50, all right, which is where Theo gets it right and I get it wrong. Okay, because I would have, and I did, when I did my own answer, I went, well, that's the y-intercept right there. Okay, because I did not look down here at this 20. All right, so therefore it cannot be that one. If that's 20 and it crosses at 167, it has to be B. All right? So even I can get tricked, guys, so make sure you're reading things properly. All right? You've seen this before. If you haven't got those equations written down, you're in trouble. You guessing?
No.
Liar. In 9 seconds. Couldn't have calculated in 9 seconds considering you don't even have a calculator. It's Mitch's. Show me your calculation that's on it then. Quick, type it in before I get there. Alright, so we've all answered, haven't we? Because we got 6 there. Oh, hit the button. Alright. So, with those 2 equations, Theo, you should have been able to work it out. Did you work it out or did you just guess? Be honest. Right. I don't want you just guessing. Alright, I've said this before. If you're going to just guess, then you're wasting your time. Alright, if you're going to try and work it out, even if you risk being wrong, you're going to learn from it. Okay? So the same two formulas we had at the start for that first question. M equals R SY over SX. Okay? And C equals Y bar minus M X bar. Okay? You should have been able to work that out quite easily. This is the last question. I think it's the projector again. The squeaking one. I think it's that again.
What's the time now?
10:33. All right, who's still yet to answer? Sorry, for predicting. Yeah. It comes back to knowing what it means. All right. You work it out? Educated guess. All right. So, if you're doing, I can't now. If you're doing any one of these, like I've said in the past, okay, what you need to do is put that data into your calculator. Okay, and do that on your calculator. Then you just fit a least squares regression line. You graph 1 on x against y, you fit a least squares regression line, you're going to get the gradient, the slope. Alright? I think that's it. Alright, so I'll turn all the clickers off.